In this lecture, we're going to explore the size of polymorphic objects, or objects that use dynamic binding, and we're going to learn about the concept of slicing if you happen to assign a derived object to a base object. We're going to see how this works out. In the last two lectures, we saw that we could achieve static binding using a setup like this. We can set up an inheritance hierarchy, and we're going to have oval derive or inherit from shape, and we're going to have circle inherit or derive from oval here. And our methods are going to be raw. They are not going to be virtual on anything. And this is going to do static binding. If you happen to manage a derived object through a base pointer or reference, you want to get dynamic calls. You will get static binding, and the compiler will use the base pointer or base reference to decide which draw method to call on your object. We also saw that we could achieve dynamic binding using virtual functions, and all we needed to do was mark our methods as virtual in our inheritance hierarchy here, and this would give us polymorphism or dynamic binding. But one thing you should know is that dynamic binding is not free. You're going to be paying in terms of memory to get all these cool things we saw in the last lecture. And we're going to be proving that in this lecture. What we're going to be doing is basically set up our inheritance hierarchy, and we are going to set that up in such a way that it is going to be using static binding. We're going to see the sizes we get printed out here, and we're going to use dynamic binding and compare these sizes. And the constatation is going to be that with dynamic binding, your objects are going to be much larger because your C++ program will need to keep track of the information that allows it to resolve function calls dynamically. And that information is stored in what we call virtual tables, but I am not going to go into that here because it is really out of scope of a course like this. But I want you to be aware of this. If you use dynamic binding, your objects are going to be much larger. Okay, the first thing I want to bring your attention to is object slicing. And we're going to look at a simple example here. We have our objects, we have a shape object, we have an oval object, and we have a circle object. And down here, we want to assign our circle object to a shape object. Now, notice that here we are not using a pointer or a reference. These are just raw objects that we are assigning to each other. And what the compiler is basically going to do, it's going to notice that a circle has a shape poured into it. And it is going to strip off the outer layers, or in other words, it is going to strip off the circle layer, it is going to strip off the oval layer, and it is going to leave in the shape part, and that's what it is going to assign to our shape object here. Let's visualize this. Our shape class looks like what we have here on the left. Our oval class has a shape part into it, and our circle is going to have an oval part into it, and that oval part is going to have a shape part of it, and this is the setup that we have here. Now, if we do our assignment, we're going to do something like this. The compiler is going to see that we are really assigning a circle to a shape, and the compiler is going to notice that what we have on the left is just a shape, and we don't have enough space to store information about oval and circle here. So what the compiler is going to do, it is going to strip off all these things that we don't really need, and it is going to leave in only the shape part that we can assign on what we have to the left. So it is going to strip off all these things, and we are going to be left with something like this. And then what we have on the right is going to be assigned on the left, and we will have our data stored in our shape2 object. And if we try to use it, that's what you're going to get in memory. So this is referred to as slicing. Again, the compiler is going to notice that it doesn't really have enough space on the left to store everything we have to the right of the assignment here. And it is going to strip off or slice off everything we don't need. And it is only going to leave in the shape part. And that's what it is going to assign on our object that we have on the left of the assignment operator here. And this is referred to as slicing in C++ terminology. I just want you to be aware of this, and we're going to see a lot of this starting from now. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is size of polymorphic objects and slicing. We are going to grab the code from the last lecture, so let's grab everything except for the binary file. We are going to copy everything and we're going to put that in the current folder. And we're going to open this little guy in Visual Studio Code by dragging and dropping here. This is going to give us our project, and we can head over in the main CPP file and clean up all the mess we got from the last previous lectures. We can also take out these functions because I don't think we need them here. And we are going to check out on our classes. Notice that we are using dynamic polymorphism because we have virtual functions here. So if we happen to be using base pointers or base references to manage our derived objects, we will get polymorphic results. Okay, the first thing we want to see is the size of objects for our classes here because we are using virtual functions. Let's head over in the main CPP file and we're going to put in a piece of code which is just going to use the size of operator to print the sizes of objects of these classes. We can try to build and run this program. We're going to use GCC here. The build is just going to be good. We can bring up a PowerShell window we can use to run these programs. We're going to do that. New terminal. This is going to bring us our window here. We can clear and run Rooster. We're going to get 40, 56, and 56. So you see that these are our sizes. So let's say that with dynamic is going to be 40 for the base class. With dynamic polymorphism, we're going to get 56 for the oval object. And we're going to get dynamic 56 for the circle object here. Now, we're going to remove the setup that uses polymorphism and we're going to see the results that we get. All we need to do is to remove the virtual keyword here. We can comment it out. We can do something like this in shape, and we're going to hop over in oval and comment out the virtual keyword. We can do something like this, and this is going to work without removing this completely from our code because we still need to leave this in as a reference. We're going to hop over to circle and do the same thing. And now that we have this set up, we can hop over to our main CPP file. We're going to see that we don't have any squiggly lines of some kind. So this is going to be accepted by the compiler. But if we build and run this program, we're going to see different sizes. Let's see if the build is good. It is good. As you see here, we can clear and run Rooster. Now you see that with static binding, the base object is 32 bytes. The oval object is going to be 48, and hopefully you can see that with dynamic polymorphism, our objects are going to be much larger because the compiler has to keep track of the information that allows it to dynamically resolve virtual function calls. That's why our objects are larger with polymorphism, and you should know that you are not getting polymorphic results for free. You are going to be paying in terms of much more memory that you use for your objects in your C++ programs. This is the first thing I want you to see in this lecture. The second thing I want you to be aware of is the concept of slicing. And this is going to happen if you happen to take a row derived object and assign that to a row-based object. Let's do something like that. We are going to create a circle object, and then we're going to say shape, and say shape here. And we're going to say equals circle1. This is something we could do, but notice that the compiler is not giving us any kind of compiler error because we can assign a circle to a shape because a circle is really a shape. But from what we know in our inheritance hierarchy, a circle is really much more than a row shape. A circle has oval information in it, and it also has circle information in it. So it is really much larger and much wider than a shape object. But the compiler is going to see that we are trying to assign a circle to a shape, and it is going to be smart enough to know that we don't really need oval and circle information in our shape object that we are storing here. So the compiler is going to slice off circle and oval information, and it is going to leave in shape information. And that's the only thing we will be able to use with this shape variable that we have in our C++ program. So if we say shape draw, you can try to guess what we are going to get. And let's go back and re-enable polymorphism, because some of you might think we are going to get polymorphic results with this setup here. That's not what we're going to get, because we are not going through base references or base pointers to do what we are doing in this example on slicing here. So because we are not using base references or base pointers in this line here, the compiler is going to see that these are raw objects, and it is going to do slicing and slice off things we don't need in our shape variable that we are setting up on line 16 here. So if we call the draw method, this is going to call shape draw. It is not going to do dynamic polymorphism here. You should be aware of this. If you're not using base pointers or references and you hope to get dynamic polymorphism results, I hate to break it to you, but you're going to be disappointed, because the compiler is going to slice off derived class information, and all you're going to be left with is base class information here. That's why this is going to call shape draw. Let's build and run and really make you see this. This is going to go through GCC, our favorite compiler. The build is going to be good. We can clear and run rooster. You're going to see that it is going to say shape draw. Even if we tried to assign a circle to a shape here, this is going to disappoint us, because this is really going to slice off circle and oval information, and it is just going to leave in the shape nucleus that we have in our circle object here, if I can say it like that. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to see what happens if we try to store polymorphic objects in collections. Go ahead and finish up here and meet me there.